Hi everyone, we're going to do section 1.6. So 1.6 is about inverse functions. Basically, two functions are inverses if their domains and ranges flip-flop roles. Okay, so for instance, I'm going to put two functions up here. F of x equals 2x minus 1, and we'll do two different colors here. We got g of x equals x plus 1 over 2 are inverse functions. Okay, so if I look at a t-chart for f of x, right, I'm just going to choose some numbers. Let's do like x equals like -1, 0, 1, and 2. Okay, we're going to do a little mental math here. 2 times -1 is -2. -2 minus 1 is -3. 2 times 0 is 0. 0 minus 1 is -1. Then so on and so forth. We get those 4 points. So what happens with an inverse function is those 4 ordered pairs get flip-flopped. So -1, -3 is on the graph of f of x. On the graph of g of x is going to be -3, -1. So you see the y's of the f of x became the x's of the g of x. So let's mental math this again, just to double check. -3 plus 1 is -2. -2 over 2 is -1. -1 plus 1 is 0. 0 over 2 is 0. 1 plus 1 is 2. 2 over 2 is 1. 3 plus 1 is 4. 4 over 2 is 2. So you can see the 4 ordered pairs of the f graph and the 4 ordered pairs of the g graph are totally opposites of one another. So let's draw these two graphs to notice something cool about what happens. So we'll draw the g or f of x in green. So -1, -3, 0, -1, 1, 1, and 2, 3. We connect the dots here. And we get, there's my f of x graph in green. Here's my g of x graph in purple. So -3, -1, -1, 0, 1, 1, and 3, 2. So the g of x graph looks like this. And if you notice, there's actually reflections around this line right here. Because so if I took the green and purple graphs and I reflected it around that line right there, you're going to see that is the line y equals x. That is a trait of inverse functions. They're always reflected around that y equals x line. All right, so let me write that down. A function and its inverse are always reflections about the line y equals x. All right, they're always reflections about that line. So that's gonna come up in the MyOpenMath like a true false or something. So just be aware of that when it happens. Okay, so how do we notate an inverse function? Here's how we notate it. F with a little -1 up here of x means the inverse of f of x. So we say it f inverse of x. Okay, caution, in MyOpenMath is going to try to trick you at times. F inverse of x does not equal 1 over f of x. Right? If you saw the expression 5 to the -1, well, 5 to the -1 means 1 over 5 to the first. But in this case, it does not mean that. It does not mean reciprocal. Alrighty. So, if f of 3 equals 11, then we could safely say that f inverse of 11 equals 3. Because the output of the f function becomes the input of the f inverse, and vice versa. Another thing we can say is if f inverse of 3 equals 2, then f of 2 equals 3. If, and here's where my open math is going to try to trick you, if f of 7 equals 8, then what does f of 7 to the negative 1 equal? Well, this time the negative 1 is not placed between the f and the 7, so this one actually does mean reciprocal. So we're going to say this means 1 over f of 7. So that'd be 1 over 8. So you have those kind of trickerations that are going to come up. Alrighty. Okay, what if I gave you a table of values so we could answer some inverse questions based on this table of values? So I have x, and then we have f of x. So if I have x's 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have f of x equals 3, 4, 2, 8, 1, 7, 6, 0, 9, 5. I asked you some questions on this. Alright? What if I ask you, what does f of 3 equal? So if I ask you what f of 3 equaled, you go down here to x equals 3, track over f of 3 equals 8. What if I ask you f inverse of 7? So let's talk about what that really means. So this means use f of x values as inputs and x values as outputs. So we're going to go down the f of x list and look for 7. So you go down here to f of x list, look for 7 right there. The x value that gave us 7 was 5. So f inverse of 7 equals 5. F inverse of 0. So you're going to go find 0 in the f of x column. 0's right here. The x that got us there with the f of x function is 7. So the output of the f inverse is 7. Alright? If f inverse of x equals 8, then what does x equal? So this tells you the output of the f inverse function is 8. So we're looking for 8 here in the outputs, right? The outputs of the inverse function are the x values. So we're going to go down here and look for 8. So 8 is right here. 8 is the output of the inverse function. What do we have to input in order to get that output? We had to input 9. So x equals 9. Alrighty. Okay, so that was fun with tables of values. So you'll have a couple of those on My Open Math. Let's do another example. Here we go. I gotta get us a fresh page of notes. And we'll do another example. What if I give you, remember, if I'm going too fast for you, pause as you're going through it. Or play me on a slower speed. I already talk kind of slow, so that'd be kind of weird. If I give you this graph, or this table of values right here. So 3, 4, no, I'm going to go 3, 6, 9, 12. 3, 6, 9, 12. And I tell you my outputs are 4, 8, 12, and 16. I tell you this right here is a table for f of x. And I want you to give me a table for f inverse. Okay, so we're going to do a table for f inverse. Alright, so if we got anything out of this lesson, f and f inverse switch roles. So the range of the regular function 4, 8, 12, and 16 becomes the domain of the inverse. So 4, 8, 12, 16 become my x's, and then the x's of the f function become the y's of the inverse. So 3, 6, 9, 12 would be the y's of the inverse. So there's your table for f inverse of x. Alright, now what if algebraically you wanted to find the inverse function? So for instance, what if I give you this one right here? Find f inverse of x for f of x equals 7x minus 12. Alright, we want to find the inverse function for that. So, algebraically, here are the steps. I'm going to show you two different ways and you can choose the one you like better. The first way I'm going to show you is going to work for all of them. The second way, you're going to have to get kind of crafty with it to work for all of them. So the first way is a better way to learn it, in my opinion. So we're going to put y in for f of x. So I get y equals 7x minus 12. That's step one. So f of x comes out, y goes in. Step two, functions and their inverses, they flip-flop x and y roles. So step two, we're going to switch x and y. So we get x equals 7y minus 12. Alright, literally switch them. Step three, you're going to solve for y. So to solve for y, gotta get y by itself. First thing you're going to do is add 12 to both sides. So we get x plus 12 equals 7y. And then I'm going to divide both sides by 7. So y equals x plus 12 over 7. That turns out to be the inverse function. But one more step, we have to notate it properly. So step 4, we're going to put f inverse of x in for y. So I get f inverse of x equals x plus 12 over 7. And there's my final answer. Okay. So the other way that works really well with these linear functions like that, because that's a linear function we just did. So the other way that works really nicely is called, and this is totally my way, made up. It's probably used by someone else in the universe, but I like to call it the socks and shoes method. So if you're going to put socks and shoes on in the morning, you start with your bare feet. You put your socks on first, and then you put your shoes on. Alright, so 7x minus 12, if that was my function, if I put my socks on first, that basically means multiply x by 7. Right, so socks on, we multiply by 7. And then the shoes on, we're going to subtract 12. Okay, so that's basically what f of x did to x, right? F of x basically multiplies x by 7 and then subtracts 12. Okay, f inverse of x, I got to take my shoes off first. Unless you're some kind of wizard, you're going to have to get your shoes off first. So we're adding 12. And then we're going to take our socks off second. Alright, you got to do the opposite operation too, right? The opposite of putting your shoes on is taking them off. Opposite of subtracting 12 is adding 12. So the opposite of multiplying by 7 is dividing by 7. Okay? So that gives you your inverse function, x plus 12 over 7. Alright, so that's the socks and shoes method. Kind of fun. I actually had a kid at Churchill one time work for the whole period to get his socks off under his shoes, and he actually did it. Yeah, I made him do the homework anyway. I don't know why he thought it was necessary to do, but there you have it. By the way, not all functions have inverses. Not all functions have inverses. Okay? To have an inverse function, a function must be 1 to 1. Meaning, for every y, there's exactly 1x, and for every x, there's exactly 1y. The reason is, if you take a non-one-to-one graph and you flip it around the y equals x line, it's not going to be a function. Okay? So we could say this: a one-to-one function passes both the vertical line test and the horizontal line test. Okay, so an example, let's look at a quick example. If I just did the y equals x squared graph, so suppose I just gave you the y equals x squared graph. Okay, it is a parabola that looks like this, right? There's y equals x squared. If I were to try to flip that around the y equals x line, right? If I try to flip that around the y equals x line, it is not going to be a function anymore, is it? Check it out. Right, if I flip it around that line, whoops, I'm in dashed line mode. Flip it around that line, you end up getting this action going on. But what's the problem with that is that's not a function now, is it? That's not a function now. So that is the reason why a graph needs to be one-to-one in order to have an inverse. So how could we fix this y equals x squared graph in order so that it does have an inverse? Well, if I just looked at half of it, right, if I just did this piece of it, y equals x squared with x being greater than 0, now it's one-to-one, right? Now if I graph the inverse, it's going to look like this. So now it's one-to-one. As you can see, it passed both the horizontal and vertical line test, right? See, if I go through it horizontally, there's not going to be any time it crosses more than once. But if I did this one horizontally, right, that one fails that horizontal line test. It hits that graph more than once. So the parabola as it is does not have an inverse, y equals x squared. But if I just did half of the parabola, in other words, y equals x squared with x bigger than or equal to 0, then all of a sudden it does have an inverse. Okay? A couple more examples and we'll be done. Suppose I give you this one then, because there's one like this on your assignment. This lesson's pretty long. So let's find f inverse of x for f of x equals x minus 2 squared with x being greater than or equal to 2. So if we were to graph this one, right? X minus 2 squared is the parabola shifted right 2 units. But I only want to look at it for values bigger than or equal to x equals 2. So this graph actually looks like that. So it definitely does have an inverse because it passes both that vertical and horizontal line test. So let's choose a different color here. If I were to look at it flipped around the y equals x line, it's going to look like that, right? So I just need to find the equation of that. Now it looks like it's going to involve a square root. So y equals x minus 2 squared. I'm going to square root both sides. Or I switch x and y first, excuse me. Switch x and y first. Now I square root both sides. So square root of x equals y minus 2. Then I add 2 to both sides. And then f inverse of x equals radical x plus 2. Okie dokie. One more example. Let's do a toughie. We'll finish this section with a toughie. Okay. Toughie's a real word. You could look it up in a dictionary. Toughie. F of x equals 7 over x plus 2. Find f inverse of x. So if it tells you that, it doesn't tell you to check for 1-to-1 or not, so we're not going to worry about it. We're just going to do our process. Y equals 7 over x plus 2. Switch x and y. So x equals 7 over y plus 2. Now I have to solve that for y. So that's a tricky problem. So what I would do, I'd look at this as x over 1 and I'd cross multiply. So x times y plus 2 equals 1 times 7, which is 7. Now I'm trying to get y by itself. So you know what I would do? I would divide both sides by x here. So I get, those cancel, we get y plus 2 equals 7 over x. So then y equals 7 over x minus 2. If I subtract 2 from both sides, last step, put f inverse of x in for y. And we get f inverse of x equals 7 over x minus 2. And there you have it, everybody. Inverse functions. I hope you liked section 1.6. We'll see you in the next section, which I believe is section 2.4. See you later.